Welcome back. Our topic for today is going to be parametrized surfaces. So surfaces are a shape that's in 2 dimensions, and we typically look at them inside 3-dimensional space. And we saw these earlier in the course, especially when we were talking about graphs of functions, and we see them regularly when we're talking about other shapes as well. And there's different things that we want to calculate about surfaces, like calculating surface area or mass, or calculating later on rates of flow of a fluid through a surface inside 3-dimensional space. And these are all going to be done by basically double integrals. But in order to be able to do these, we're going to have to parametrize surfaces in the same way that we parametrized curves, or we found bounds for integration for shapes in 3D. So here's the idea of a parameterization. What it is basically a coordinate chart. It draws a set of coordinates on our 2-dimensional shape so that we can describe where the points are in terms of some numbers. So usually it comes in the form that looks like this. We say that the x, y, and z coordinates are some function of numbers u and v. And so, for example, coordinates on Earth are typically given in terms of latitude and longitude coordinates. That describes the points of Earth in terms of a pair of numbers that fall between 0 degrees and 360 degrees and fall between 0 degrees and 180 degrees, or minus 90 and 90. There are 3 main techniques we use in this class for parametrizing surfaces. And the first is recognizing them as graphs of functions, or if you like, you can think of this in terms of solving for one variable in terms of other variables. The second technique we have is that certain surfaces look really nice inside certain coordinate systems. If something's round, it typically looks good in spherical coordinates. If something's cylindrical or kind of cylindrical, it looks good inside cylindrical coordinates. And we have certain special examples for parametrizing shapes that show up all the time, triangles and parallelograms inside 3-dimensional space. And so we'll go over these 3 techniques over the course of this lecture.